Okay, so in this video here, we're going to be talking about how to rationalize the denominator. And in this video, we're going to be talking about only real numbers. I actually have another video on rationalizing the denominator with imaginary numbers or complex numbers. So I'll go ahead and link that in the description box below. That way you have access to that content. But this video here is going to be only on real numbers, okay? And so let's talk about why we want to rationalize the denominator. Well, it's really simple. Okay, think about dividing by an irrational number. Look at these two examples that I have here. I have 5 over the square root of 2, and I have -9 over the square root of 5. Well, whenever you have a square root that is not a perfect square, the result will always be irrational. So for example, this square root of 2 is an irrational number. This square root of 5 is also going to be an irrational number. Now, imagine doing long division and trying to divide by an irrational number. Okay, you're going to be there all day. It's going to take forever. It's not going to be a good time. So to get around that, we do something called rationalizing the denominator, where we take the irrational parts out of the denominator. And that way, dividing the problem becomes much easier. Now, again, we have calculators today, so that's really not that big of a deal. But this is still a practice that we do in mathematics, so you want to know how to do it. Okay, so let's take a look at the first problem. I have 5 over the square root of 2. I have to get rid of that irrational part, and it's really simple. These two problems are going to be really easy. All you have to do is multiply by what you see in the denominator. In this case here, I'm going to multiply by the square root of 2. And I'm going to do that to both the numerator and the denominator. So for example, I'm going to multiply here by the square root of 2, and I'm going to multiply here by the square root of 2. And then just going from top to bottom, I know that 5 times the square root of 2 is going to be 5 square root of 2. All over, well, the square root of 2 times the square root of 2 is going to be 2. So I'm going to put 2. I'm done. I just went ahead and rationalized the denominator. Now, let's be really clear here. If I were to plug this answer here into my calculator and compare it to this right here, you're going to get the same value. But again, we did talk about why we are in fact rationalizing the denominator. So just keep that in mind. You are going to get the same answer, but the proper way of doing it is to take the irrational parts out of the denominator. Okay? Let's take a look at the next problem. So here I have a square root of 5. I'm going to multiply both the bottom and the top by the square root of 5. So doing that right here and right here, I'm going to be left with -9 square root of 5 all over 5. All right, super easy, really nothing to it. These problems are definitely easier. And so from here, why don't we go ahead and try problems that are a little more difficult? So here's our next problem, and you can see it's going to be a little bit more challenging because I have this 5 here. I don't just have the square root of 2. And so what's going to happen here, if you try to multiply both the bottom and top by the square root of 2, what happens? Well, what ends up happening, you have to distribute that square root of 2 to both the 5 and the square root of 2. So on your denominator, you're going to be left with 5 square root of 2 plus 2, okay? And that doesn't help because I still have this irrational part right here. So what do we need to do here? So if we have more than one term and they're asking us to rationalize the denominator, there's actually a method you have to use here, okay? And that is going to be multiplying by the conjugate. All right, so let's go ahead and get rid of this here. And so it's really simple. The conjugate is just going to be the opposite part of the square root. So if I have a positive square root of 2, that means a negative square root of 2 must also exist, right? Because when we take the square root of a number, it's always plus or minus. So what you want to do to rationalize the denominator here is multiply by the conjugate. Now, when you multiply by the conjugate, the non-square root part is going to stay the same. So in this case here, 5 is going to stay the same. It's just going to be the square root part that changes, so I'm going to use the opposite sign, which is going to be minus, right? So minus square root of 2. And I'm going to do that on the numerator as well. So 5 minus square root of 2. So definitely a little more work here because we have to FOIL, right? So on the denominator, we have to FOIL this out. When we do that, you're going to get 5 times 5, you get 25. And here's the deal. When you multiply by the conjugate, outside and inside will always cancel out when you're doing FOIL. If you can remember that, you don't even have to do it. But I'll show you right here. When I do outside, I get negative 5 square root of 2. When I do inside, I get positive 5 square root of 2. And you can see how these terms are going to cancel each other out. So whenever you multiply by the conjugate, and it could even be the complex conjugate, again, that's getting into imaginary numbers, the outside and inside terms will always cancel out when you do FOIL, all right? And now when I do last, I have to do the square root of 2 times negative square root of 2. That's going to give me negative 2, okay? And then just combining like terms right here, I have 25 minus 2, that's going to give me 23. So I get 23 on my denominator, all right? I'm just going to underline it so I don't forget. And now I just have to do the numerator. All I have to do is distribute this 5 inside parentheses 2 times, and I'm done. So 5 times 5, that's going to be 25. And then 5 times negative square root of 2, that's going to be negative 5 square root of 2. All over my denominator, which was 23. Okay, and that is it. So that's all you have to do here, and that is going to be rationalizing the denominator in this particular example. All right, so again, just to be clear, if you were to plug both of these into your calculator, you take this right here, plug it in, you take this one here and plug it in, you're going to get the same value. All right, but remember, the proper way of doing it is taking the irrational parts out of the denominator. All right, let's try one more example. So here's our last example, and this is definitely going to be the more challenging of the three, but it's pretty much the same principle. You can see that I have a negative square root of 6 in my denominator, and I also have this positive 2. I'm going to have to multiply by the conjugate. All right, so that's what I'm going to do here. I'm going to multiply by 2 and then plus square root of 6. And I'm going to do that to the numerator as well. So 2 plus square root of 6. And we're going to have to do FOIL on both the numerator and denominator. Now remember, when you multiply by the conjugate, the outside and inside terms will cancel out. So when I'm doing the denominator, all I have to do when I do FOIL is first and last. Okay? So that's what I'm going to do. So in other words, I just have to do 2 times 2, that will give me 4. And then I have to do last, which is negative square root of 6, times positive square root of 6. That's going to give you negative 6, okay? And then just combining like terms, 4 minus 6, I get negative 2. Okay, so there's my denominator. I get negative 2. Now I have to do the numerator. Now be careful here. This is not the conjugate of what you have here. Okay, so in this case here, you have to go through the whole process of FOIL. All right, outside and inside will not cancel out here. All right, so let's go ahead and do that. We're going to do 7 times 2. You're going to get 14. Now doing outside, you get 7 square root of 6. And then inside, you get plus 2x. And then last, you get plus x square root of 6. Now this one's really weird because you don't actually have any like terms. If I look at my numerator, what I have when I simplified it out, there's no like terms that I can combine here. So as a result, I'm just going to write it as is. So my final answer is going to be 14 plus 7 square root of 6 plus 2x plus x square root of 6 all over negative 2. Okay, there it is. So this problem is now done. Now, if you wanted to, you could take this negative and you could redistribute to the numerator if you wanted to do that. If you don't want to have that negative number in your denominator, that's totally fine. I'm just going to leave it there. It's the same thing. All right. So that's done. So that is how you rationalize the denominator when you're dealing with real numbers. It's a little bit different when you're dealing with imaginary numbers and complex numbers. Again, you're going to be dealing with I in that case. I do have a video on that. I'll go ahead and link it in the description box. That way you have access to that content. But if you found this video helpful, please go ahead and give it a thumbs up. That would be greatly appreciated. Also, make sure you subscribe so you get more math videos in the future, and I'll see you in the next one.